Hi, my name is Caitlin, and today I'm going to be talking about classes and objects in C++. First, let's define what a class is. Classes are a very important building block of C++. They are data types that you define, and they hold functions and data. Essentially, a class is like a blueprint. Here is an example of a class. I used the car class. There are many different makes and models of cars, but they also have things in common, like having wheels and mileage. In this example, the class is a car, and the mileage and wheels are the properties of the car class. Now, on to defining a class. This is done by using the keyword class followed by the name of your class. As you can see below, the yellow represents the keyword class and the green would be your class. C++ allows the programmer to define their own function. A user-defined function groups codes to perform a specific task, and that group of code is given a name. When the function is invoked from any part of the program, it all executes the code defined in the body of the function. This is how user-defined functions work. When a program begins running, the system calls the main function, so the system starts executing codes from main function. When control of the program reaches to function name inside main, all codes inside void function name are executed. Then control of the program moves back to the main function, where the code function name is executed. Now, let's talk about objects. The definition of an object, put simply, is an object is an instance of a class. When a class is created, there is no memory until you define an object. This is how to declare an object. When you create your class, there's just a frame for your object. The object is empty until you define it and give it a purpose. To use data and access the function in your class, you have to create your object. The basic syntax for an object is below. Starting with your class name, followed by the name you give your object. Now, our member functions. A member function of a class is a function that has its definition within the class, like any other variable. It operates on any object of the class of which it is a member, and has access to all the members of a class for that object. Member functions can be defined within the class definition or separately using scope resolution operator. Next is accessing data in member functions. To include these, all you have to do is use the dot operator with your object. For example, if you want to access the member function in green, you would write what is in yellow. Now, let's talk about assessors and getters. An assessor is a member object that does not modify the state of an object. The function should not be declared as constant. Getter is another common definition of an assessor due to the naming getSize of that type of member functions. Now let's talk about overloading. Member functions can be overloaded. This means that multiple member functions can exist with the same name on the same scope, but must have different signatures. A member function signature is comprised of the member function's name and the type and order of the member function's parameters. If a member in class shares the same name with members of the base class, they will be hidden to the compiler. To make these members visible, one can use declarations to introduce them from base class scopes. Constructors and other class member functions, except the destructor, can be overloaded. A friend function of a class is defined outside that class's scope, but it has the right to access all private and protected members of the class. Even though the prototypes for friend functions appear in the class definition, friends are not member functions. Now, public versus private data. The public data members are accessed with the dot operator as mentioned in the slide before. The private data members are not allowed to be accessed directly by the object. Accessing a data member depends solely on the access control of that data member. The three access modifiers are public, private, and protected. Now let's talk about constructors. This is executed whenever you create new objects in a class. A constructor has the exact name as its class, and they are useful when setting initial values. Last are destructors. These are executed when the delete expression is applied to an object. Just like constructors, these have the same name as the class but are followed by the squiggly symbol. That wraps up the basics of objects and classes in C++. In the end, classes and objects go hand in hand to build a backbone and blueprint for your codes. They work together to let you customize and accomplish the specific needs of your code. I hope this taught you a little bit about the basics of objects and classes in C++.